Right, hello everyone. So we focus on the salt hydrolysis for the problems and questions. The topic of this session, you should be able to solve the pH calculation involving the salt solution. So this session, I'm going to show you 3 examples regarding the calculations. Okay, so before we perform the calculation, let's bring this. So what is this? Actually, is a step to calculate the pH or pOH of the salt solution. So the concept is similar to the weak acid and the weak base, where you need to calculate the pH and pOH using the ice table. So from this ice table of the salt solution, the equation that needs to enter in the table must be the salt hydrolysis equation. Okay, from the ice table you will get the Ka or Kb. If it is an acidic salt, so you will use the Ka. If it is basic salt, you will use the Kb. The value and the Kb will be given to you. Alright, from the Ka and Kb value, so you will have find the concentration of hydrogen ion or hydroxide ion to find the pH and the pOH. Okay, so this is the first example. So the first example says that the salt solution was produced by dissolving the 5 grams of the salt ammonium chloride NH4Cl in 500 ml of distilled water. Then you need to calculate the pH of the salt solution. And given to you, the Kb value for the NH3 is 1.8 times 10 to the power of negative 5. Okay, so this is the ice table. So where I is referring to the initial. So C is for the change. E is for the equilibrium. So this, for the first row, you have to fill in the salt hydrolysis equation. So how to have the salt hydrolysis equation? So this is your salt, NH4Cl, this one. NH4Cl, so plus water, because it is in water, so you will have NH4 plus and Cl minus from the salt. So positive one will attach to hydroxide from the water and Cl minus for the hydrogen ion. So H4 plus comes from the weak base. HCl is from strong acid. So if it turns to the conjugate, weak base will be strong conjugate acid. Strong acid will be weak conjugate base. So only strong conjugate will have a reaction with the water hydrolysis. So this one we will use for the hydrolysis equation. So NH4 plus water. So NH4 plus is the strong conjugate acid. So it will act as acid here. So acid will donate the proton. So from NH4 plus, we will have NH3. So the hydrogen will donate to the H2O. So we will got H3O plus here. So the presence of H3O plus will confirm it as the acidic salt. Okay, since it is acidic, so you will have the Ka. So, but what are given to you is the Kb. So you need to find the Ka value. So Ka times Kb equals to 1.0 times 10 to the power of negative 14, the Kw value. So Ka will be equal to 1.0 times 10 to the power of negative 14 divided by the Kb value, 1.8 times 10 to the power of negative 14. You will get 5.56 times 10 to the power of negative 10. Okay, so Ka also from the isable is product over reactant. So the product is NH3 concentration NH3O plus over the reactant is NH4 plus excluded the water. So what we'll need to fill in here, so N is the molarity, the concentration in molarity for each of the substance. But you are not given the molarity of the salt, but you are given the mass here. So you need to find the molarity. So how to find? Similar, same formula. N is mole. What is mole? Mole is S over molar mass. So the mass is 5 gram divided by 53.5 gram per mole. So it will be 0.09 mole. Okay, the molarity, mole per volume. So the mole is 0.09 mole. The volume that used here is dissolved in 500 ml. So convert in liter, so 0.5 liter. So the molarity will be 0.19 mole per liter. So this will be 0.19, nothing for the water. So for the initial, there will be 0 for the product, no addition yet. And after the reaction occur, the change will be negative X for the reactant, excluded the water. So NH3 will be positive X. This one will be positive X. Equilibrium, just add INC. 0.19 minus X. And NH3 X. Water also X. So the Ka, NH3 is X. H3O plus also X. So X squared over 0.19 minus X. So the minus X here can be ignored because the value of Ka is less than 10 to the power of negative 4. So it will be X squared over 0.19. Okay. So from Ka value, so since Ka is 5.56 times 10 to the power of negative 10, so you can find the X value because X is equal to H3O plus. We need the H3O plus because you will need to find the pH, because pH equals to negative log hydrogen ion concentration or hydronium. So what is X? So X will be Ka times 0.19 square root. Then you calculate, you will get how much? 1.03 times 10 to the power of negative 5 molar. So insert the formula, the value in the formula. So negative log 1.03 times 10 to the power of negative 5. So you get 4.99. Is it? So that's for example 1. This is for the salt. This one is for the basic salt, but before that you need to confirm first is it basic or acidic. So similar to the previous example, you need to have the salt hydrolysis first. So this is the CH3COOH. Sorry, CH3COO and A is the salt. You need to find the conjugate first. So plus water, CH3COO minus plus and A plus, so minus will attach to the hydrogen ion. This one is for the hydroxide. So NOH is a strong acid, so it will be weak conjugate base. CH3COOH is the weak acid, so it will be strong conjugate base. So CH3COO minus as the strong conjugate, so we have to use it as ion for the salt hydrolysis. I think I need to change the color. CH3 COO minus, so plus water. So since it is strong conjugate base, it will as base, so base will accept the proton. So CH3 COOH plus accept the proton from the water, so H2O will be hydroxide ion. So the presence of the hydroxide confirm it as the base salt. Alright, similar to the previous one also. So initial is I, C, and E. So at I, this one is the molarity 0.56. So 0.56. Nothing for the water. So I just cancel it. CH3COOH 0, 0 at initial. This one also minus X. This one is plus X. This one is plus X. Equilibrium 0.56 minus X. CH3COH is the plus X and plus X. Alright, so it is a basic salt. So you will have the Kb. So Kb here is product of a reactant CH3COOH. Hydroxide ion concentration, and the reactant is CH3 COO minus. So insert the value, so it will be X and X squared over 0.56 minus X. So the Kb value, the Kb value is not given because you are given the Ka value. So you need to find the Kb value. So where Kb equals to Kw over Ka, so Kw also the same value, negative 14 divided by the Ka value 1.8 times 10 to the power of negative 5. So you will get 5.56 times to the power of negative 10. So because it's less than 10 to the power of negative 4, so this minus X can be ignored. So this one will be equal to X squared over 0.56. So you need to find the X, where X is hydroxide ion concentration. So X will be Kb times 0.56 square root the value of that. So you will get 1.76 times 10 to the power of negative 5. So from the hydroxide ion concentration, you will have two options to find the pH, whether from the hydroxide ion, whether from this hydroxide ion you find the POH, where negative log of hydrogen ion concentration, or from the hydroxide ion. So you find the hydrogen ion first, then you find the pH. So either one you can use. So if you use the first option, you find the pOH, then you will get the pOH will be equals to 4.75, where the OH, you just insert this value 1.76 times 10 to the power of negative 5. And from the pOH value, you find the pH, where pH plus pOH is equal to 14. So pH will be 14 minus pOH. So 14 minus 4.75. So you will get 9.25. So similar to the second option, so hydrogen ion. So you find the hydroxide, where hydroxide ion will be 1.0 times 10 to the power of negative 14 divided by the hydroxide ion concentration, 1.76 times 10 to the power of negative 5. So you will get the hydrogen ion is 5.68 times 10 to the power of negative n. Then pH will be negative log hydrogen ion concentration. So you insert the value, this value. So you got the same answer, 9.25. Okay, for the last example, so what I given to you is compute a mass in N for ammonium chloride NH4Cl when it's added into 1 liter in order to obtain the solution with pH 5.967, and given to you the molar mass and Ka value for the NH4 plus ion. Alright, so similar to the other examples, we will have the ice table and we will have the hydrolysis equation. So kita ada NH4Cl, so we will have NH4 plus and Cl minus, dissociate water. So this one from the base, so it will be strong conjugate acid. So Cl minus, so it's from the strong acid, it will be weak conjugate base. So this one is the strong conjugate. So NH4 plus will form the hydrolysis with water. So plus water. So it is strong conjugate acid. As acid don't need a proton. So from NH4 plus to NH3, so the hydrogen will be donate to the water. So plus H3 O plus. So since we have the H3O plus at the product, so it is an acid. So when it is an acidic salt, so you will have to use the Ka. So Ka are given to you. So with Ka from the ice table is NH3 ion NH concentration times H3O plus ion concentration. So divide by NH4 plus, where Ka is 5.6 times 10 to the power of negative 10. Right? Okay. So we fill in the table. So you are not given the molarity and also any information to calculate the molarity. So we assume NH4 plus ion concentration as A, or any letter you want to use. So H2O, I cancel it down. So this one is 0, 0. Change negative X, positive X for the product. So this at equilibrium A minus X, yes, this one is positive X and positive X, and you are given to you is the pH. So pH is 5.67. So you can find the concentration of hydrogen ion, 3O plus ion, because you are given the pH value. So pH also is negative log hydrogen ion, so equals to 5.67. So to find it, it will be hydrogen ion shift log negative 5.67. So you will get 2.51 times 10 to the power of negative 6. So H3 plus will be the X. So this one will be X squared over A minus X equals to 5.6 times 10 to the power of negative 10. So this negative X can be ignored because the Ka value is less than negative 4, 10 to the power of negative 4. So you can find the value, the concentration. So where A will be X squared divided by the Ka value 5.6 times 10 to the power of negative 10. So where X is 2.5 times 10 to the power of negative 6. So I've continue here. So X will be 2.51 times 10 to the power of negative 6 squared divided by 5.6 times 10 to the power of negative 10. So the A will be 0.01 more. So you need to find the mass. So you have the molarity in mole per liter. So you will get the mole, and the mole you can find the mass. So the mole will be N equals to 0.01 mole per liter. So the times the volume. So the volume is given to you 1 liter. So times 1 liter, so you get 0.01 mole. So mass will be 0.01 mole times the molar mass. The molar mass is 53.5 gram per mole. So you will get 0.60 gram. So this is the mass of in gram for the ammonium chloride. Okay. So that's all from me. So you can revise the example or other questions from your reference. So that's all. Thank you for watching.